Today we're looking at question 4 on the Fall 2021 Exam 2. The question states, which of the following input sequences generates the following binary search tree? In general, in binary search trees, the way that we insert values is that we first look at the root value and we compare the value that we want to insert to the root. If the value is greater than the root, then it goes to the right subtree. If the value is less than the root, then it goes to the left subtree. We then look at that left subtree or right subtree that we go to as the new root, and we compare it again. And we're going to keep doing that process until we get to a point where there is no new node, and we get to insert our new value at that point. Let's do this as an example. This is the tree that we're trying to get. The first sequence, though, that it offers us to possibly get this tree is 5, 2, 1, 3, 8, 6, 7, 10. First value that we're inserting here is 5. The 5 just goes ahead and gets inserted as the new root because there is no value in the tree yet. The next value that we insert is 2. We look at the 2 and we say, is 2 less than 5 or greater than 5? 2 is less than 5, so the 2 goes to the left subtree of 5. Because there is no node to the left of 5, we just go ahead and insert the 2 at that point. Next we look at 1. We say, is 1 greater than or less than 5? 1 is less than 5, so it goes to the left subtree. And then again, we repeat the process with 2 now. We say, is 1 less than 2 or greater than 2? It's less than 2. And so the 1 goes to the left of 2, and it gets inserted as a new node because there is no node there. Next, we have a 3. 3 is less than 5. 3 is greater than 2. So it goes to the right subtree of 2. Next, we look at 8. 8 is greater than 5, so it goes to the right subtree of 5. Next, we look at 6. 6 is greater than 5, but it's less than 8, so it goes to the left subtree of the 8. Next, we look at 7. 7 is greater than 5. 7 is less than 8. 7 is greater than 6. So this goes to now a third level, down here to the right subtree of 6. Lastly, we have 10. 10 is greater than 5. 10 is greater than 8. So it goes to the right subtree of 8. Now we have our new binary search tree. We can compare it to the binary tree that we were given originally, and we can see that it does not match. We've got an 8 where the 7 should be. We've got a 7 coming out down here, whereas our actual subtree, the actual tree that we're trying to get, instead extends off of this node. Overall, A is not the correct answer. Next, we want to look at B. The sequence for B given is 1, 2, 3, 5, 6, 7, 8, 10. We insert the values in this order. The first node we have 1. 2 is greater than 1, so it gets inserted to the right subtree. 3 is greater than 1, and it's greater than 2. So it gets inserted to the right subtree of 2. 5 is greater than 1, it's greater than 2, it's greater than 3, so it gets inserted to the right subtree. And as you'll see, this is a pattern, that this is what we call the worst case scenario for binary search trees, and that every value is ascended from the value before. This is a non-descending order. In other words, we will continue to go to the right subtree of the last inserted node over and over again. I'm actually going to run out of room here. We insert a 7, an 8 is greater than 1, greater than 2, greater than 3, greater than 5, greater than 6, greater than 7. 8 gets inserted down here, and will get inserted down here. Really didn't run out of room. This is obviously not the binary search tree that we're trying to look for. We will go over and put it to the side. I went ahead and put the binary search tree that we got for A down there as well, just to leave ourselves a reminder of what it looked like. A and B are not the correct answers. Next we have C. the sequence that we were given for C is 1, 3, 2, 6, 10, 8, 7, and 5. First, again, we insert the 1. Next, we insert the 3. 3 is greater than 1, so it goes to the right subtree. Next, we insert 2. 2 is greater than 1, and 2 is less than 3, so it goes to the left subtree of the 3. 6 is greater than 1, and is greater than 3, so it goes to the right subtree of 3. One thing that you may already notice from doing all these is that in order to have the binary search tree that we were given, we need to have the root be the first value that we're given in the binary search tree. In other words, the first value in a sequence that is inserted into a binary search tree will always be the root. So we already know this is not going to be the correct one. We're going to go ahead and finish it out there real quick. 10 is greater than 1, 3, and 6, so it inserted here. 8 is greater than 1, 3, and 6, but less than 10. It goes here. 7 is greater than 1, 3, and 6, but less than 10 and less than 8. So it goes here. 5 is greater than 1 and 3, but is less than 6, so it goes here. In other words, C is not the correct answer. D and E, we are given, both of them have 5 as the initial starting value for the sequence, so but both of these have not set off our little alarm yet. Either of them could be correct. First, we're going to look at D. D is 5, 2, 3, 10, 8, 1, 6, and 7. First, we insert the 5. To the left of the 5, we insert the 2, because 2 is less than 5. 3 is greater than 2. 3 is less than 5, then is greater than 2. So we insert the 3 to the right subtree of 2. 10 is greater than 5. 8 is greater than 5, but less than 10. 1 is less than 5 and less than 2. 6 is greater than 5, less than 10, and less than 8. 7 is greater than 5, less than 10, less than 8, and greater than 6. Unfortunately, this does not look like what our binary search tree is attempting to be. Hopefully, E will be our answer that we're looking for. Otherwise, we may have a problem. Our sequence for E is 5, 2, 3, 7, 8, 1, 6, 10. We insert 5 as our first value. 2 is less than 5. 3 is less than 5 and greater than 2. 7 is greater than 5. 8 is greater than 5 and greater than 7. 1 is less than 5 and less than 2. 6 is greater than 5 and less than 7. And finally, 10 is greater than 5, greater than 7, greater than 8. So we are left with a binary search tree that now looks identical to the one that we are given. So E is, in other words, the correct answer.